Hello friends, Java records were introduced in JDK 14th, and with the release of Spring Boot 3.0 and Hibernate 6, you should start using them as data transfer objects. For instance, select a subset of the data from a database, package the result set in a Java record, and send it back to your client applications. Alright, so let me show you how to use the latest features of the Java and Spring ecosystem when you use YugabyteDB. Let's go. Alright folks, let me show you around. For my experiments, I'm going to use the Chinook database. Think of it as our music library that you listen to on Spotify or Apple Music. The database comes with their albums, artists, customers, tracks, playlists, and many other details. This Chinook database is deployed to my local YugabyteDB instance, and that instance is gonna be used by their application. Speaking about the application, presently I define two entity classes. The first one is the track entity, and that one keeps all of the details about a song. And the second entity class is the album one, which keeps details from the album table, right? However, this video is about Java records, and assume that you've got a new requirement. Your application needs to return short information about a track, such as the track name, the album name, and the composer, the person who created the track. And Java records is a wonderful solution for this, because you can use the record as a data transfer object. You retrieve only those details from the database that are necessary, and then you can package those details in the Java record and return it back to the caller, to your client application or to a REST API endpoint. Okay, let's move forward and implement the method that uses the track record class. I have this track service instance, and let's go ahead and come up with the most naive solution. So as long as we already have the track and the album entities, the most naive approach would be just let's use the JPA repository, let's retrieve their whole entity class using this provided track ID. This is what we are getting from the repository, and then we can use the getters of that entity class to populate our track record. That's probably the most straightforward solution, especially you already have all the entities that are necessary, but it's not the most efficient one. Let's take a look what happens. My application is here. Let's call this new method get track record for number 1. Okay, the application has started, and here as you can see that the service did what we requested. That's the track name, here is the album name and the composer of the song. But also take a look at what it cost to us. Hibernate had to generate 2 selects. The first one populated information from the track table, and it requested way too many fields. And the second request got details of the album table. But folks, we've selected so many columns from the database while our track record needs only 3 columns. That's extremely inefficient. Let's see how we can improve the implementation of our service method. For that, let me remove the current solution and show you another one. We are going to use TupleTransformers that were introduced in Hibernate 6. First, before that you had result transformers, but that interface were split into TupleTransformer and result list transformer, if I'm not mistaken. So the first step is, let's use our entity manager. We are creating a JPA query. Inside of this JPA query, we are requesting only those 3 columns, song name, title, and composer, and we are joining our track entity with the album entity, right? So, and we are providing this track ID, and then we are getting a reference to the Hibernate entity class, because the TupleTransformer is a part of the Hibernate API. So next step is, let's use this TupleTransformer. You use this query instance and you define the TupleTransformer that says that for every tuple, you will be applying this function, and the function actually creates our track record. This is how you use it as a data transfer object. So this query returns a single result because we know that there is a single result. If you need to return a list, then here is you have the result list method, right? But we need a single result. Wonderful. We optimized this solution. Let's jump back to our application and see what happens. Okay, it's starting. Okay, so their service returned the same song, the same name, album, and composer, but this solution is definitely much more efficient because Hibernate queried only those columns that were necessary, and we did not need to initialize our entity classes. What the solution did, we just straight away generated our track record, the Java record, from the tuple. Wonderful. However, that's not it. Even though this approach is efficient, what I don't like about it is that the implementation became longer, wordier. I want to have a shorter version of this implementation. And there are several solutions on how you can make this implementation shorter. One of them is the following. Let me jump back to my repository class. So right now it's just a JPA repository without any custom methods, but I want to introduce the following custom method. Here is we are defining again the same JPA query, but I want Hibernate to initialize my Java record, track record, right away whenever the data is requested. I don't want to have all that ceremony with the tuple transformers. Wonderful. And that's the name of my custom method, and the method accepts this track ID that is used within the JPA query. Looks much shorter. Let's see how it works. Going back to our service. So here is we can get rid of this lengthy implementation. And my repository, let's find the track record, and we are passing the ID. That's it, just one liner, one implementation, and we need to add the return statement. Excellent. So going back to my application, restarting this application, let's see what's happening. Wonderful, the same result, the same short query, efficient query that generated by Hibernate, and the implementation of my get track record method of the service is extremely short, right? Wonderful. But I'm still not fully satisfied. Let me go back to my track repository. So here is the query is simple and straightforward, but what I don't like is this package name. By default, you need to provide a full name of your Java record or entity class if you want to use it within a JPA query, and I don't like it. What I want to have, something like this. I want to select the data and I just want to provide a short name for my Java record. So if I do this right now, let me show you what's gonna happen. I should see an exception. What type of exception? Yep, this one. So generally, Hibernate failed to find this instance because I did not provide the package name. And there is one solution. If you know the Hypersistence project, it comes with a special feature that can help you to make this happen. So when it comes to Hypersistence Utils, several preparatory steps. Let me go to my POM XML file. First, you need to add the Hypersistence Utils library to your POM XML file. Okay. Next, you need to define a custom Hibernate integrator provider. I named it the class import integrator provider, and what you do here, you are providing your Java record class, and that class will be registered within the Hibernate environment, and that will allow you to use the short names in your JPA queries. But in the one last step, let's go to my application properties file. So here is what do you need to have. You need to add this property. You need to register your custom integrator by providing its full name. Okay, so looks like that's it. So to remind you, if I go back to my track repository, this is what I want to have, no any package names. And I've just enabled the Hypersistence Util project and configured it. So let's see what happens when I execute this application once again. I should not have voiceover off. Oops, voiceover off. We don't need a voiceover. Let's start the application. The same result, the same efficient Hibernate query, and the implementation is extremely short, and I no longer need to provide full package names. Congratulations, job done. All right, how do you like it? It was fast, easy, and contemporary. Okay, I've got two next steps for you. Give a try to Java records and make sure to use the latest versions of Spring in Hibernate. And second, drop a note if you'd like to learn more about Spring, Hibernate, and YugabyteDB. Don't forget to ring the bell and subscribe to this channel to get notified about future videos on distributed SQL. Stay tuned. Bye bye now.